Hi, Helen. Hi, everyone.
Hi, good
Can you guys hear
afternoon.
me? Good
Yeah.
afternoon.
hmm Yeah, so Mr. Jayesh Patel is an expert big data and machine learning professional, a senior IEEE member, and an editorial board member, and also an avid researcher. So today, he's working for Rockstar Games, and he's Calculative, a big data platform that lead the success of the two most financial successful media title for all time. So today he will go over how to democratize machine learning features and how to overcome challenges with us. Jayesh, would you like to try to share your screen?
Can you guys see my screen
Yeah,
now?
yeah, great.
Okay, perfect.
Yeah, we have like 1 or 2 minutes to start,
Mhm.
but you can start with like a little bit more introduction of yourself and your company. Then we can start our today's talk.
Yeah, actually, I have included the details about me and current work in one of the slides. So I don't know if we need to wait for a few participants to join, but if you are ready, we can start.
Yeah, we have like 1 more minute, so you can
Okay.
start. Yeah.
Yeah, definitely. Welcome to the session, everyone. We'll be going over democratizing machine learning features. We'll be covering why to democratize ML features, how to do it, and what are the key benefits, and how we can add value in our machine learning development process. So let me introduce myself first. Thank you, Helen, for introducing me for this presentation. I'll provide like some more details about my work and what I have been doing since last few years. My name is Jayesh Patel, and I'm currently working for Rockstar Games, the creator of GTA 5 and Red Dead Redemption. I'm working there as a senior data engineer, and I'm leading the machine learning development and data pipeline processes at Rockstar Games. I have over 15 years of experience in building data driven processes for various industries, including healthcare, pharmaceuticals, gaming, marketing services, and public transportation. My expertise is in building scalable big data analytical solutions, big data and machine learning pipelines, and analytics big data models. I'm also a senior IEEE member and contributor. I have been presenting at multiple IEEE conferences on my research in data engineering and machine learning. I'm also an editorial board member for International Journal of Data Mining and Knowledge Management Process, and also mentoring the avid researchers and other people, scholars. Here's the outline of today's session. We'll start with the overview of machine learning development process, followed by a feature engineering process. In that, I'll describe common feature engineering tasks and will provide the brief on the common challenges that enterprises face while building ML applications. I'll go over some of the key points on why and how to democratize ML features. I'll present like why and how ML democratization streamlines ML development process for enterprises. We'll also share our details about ML feature store. I'll list out some of the recent development in this area. In the end, I will conclude my presentation with the final remarks, and I'll have enough time in the end for questions and answers as well. Machine learning development process. This in this slide, I'll present the current, the common pipeline process that most of the enterprises follow to build the most common ML applications. Machine learning development is about developing the base model to solve a specific business problem. And this often involves testing various ML algorithms with right set of features to find the best performing model. And this is an iterative process, and it is often known as model training process. There are multiple players involved in developing ML applications, such as business analyst, data engineer, data scientist, and architect. It starts with understanding the business domain and the requirements. And it is the essential part in machine learning projects because, in the end, it all depends on ROIs, revenue generation, and profitability of the business investments. After identifying the use case, usually business analyst takes care of setting up the use case, hand over that things to the other stakeholders. Business analysts are the owner of this process, and it takes weeks to define a concrete use case with supporting data and documentation. Data engineers work with the analysts to extract required data sources and load them in enterprise data lake. Feature engineering follows ETL processing, and in in feature engineering, it takes most of the time to treat the incoming data to prepare enterprise ML features and feed it into the machine learning models. And ETL and feature engineering takes months to have the data ready and gather all the required features. And this is one of the most time consuming tasks in ML application development. I'll cover more details on feature engineering in upcoming slides. Data scientists usually work with data engineers to identify useful features, and data engineers are the key stakeholders here to build something so that they can feed the ML models. They work with data architects as well, software architects as well, to set up the pipeline. And as mentioned earlier, it takes months for both of these steps. Then data scientists identify the most important features that they want to use and train a model to solve a specific business problem. Base performing model is often picked up and validated as well. And it takes weeks to get a trained model with those validations. Once it's validated, the ML process is set up using pipelining methods, which generates data flow for the prediction purposes. After it gets deployed to production, the results are closely monitored by scientists and analysts, and they also set the alerts as well to check the drifting of those predictions. The modeling outcomes are often shared with the business teams to confirm the business adoption and to collect their feedback. Deployment setting alert takes weeks and require efforts from all those key players that we mentioned earlier: analysts, engineers, scientists, and architects. And this process iterates in case there are new features available or the model needs to be retrained. This is the overview of the ML development process. There might be several tweaks. Some organization might be taking different approach, but this is the generalized view of ML development process. Now, feature engineering. As I mentioned, this is one of the most time-consuming process in ML application. Now, what is feature engineering? It's the process of transforming raw data into features that better represent the underlying problem to predictive models. It is also an iterative process that interplays with data selection, model evaluation again and again. It is the art of creating predictor variables that you can use and get the most or accurate results for your predicting models. According to a survey in Forbes, data scientists spend over 80% of their time on data preparation. And there are a bunch of similar findings from several other research papers and experiences. One of the key competition that key site that hold this data science and ML application competition, Kaggle, in one of the competition, the winner is Xavier Conard. After winning the competition, he stated that The algorithms used in machine learning applications are very standard, but most of our efforts were gone in feature engineering. The data needs to be cleaned, processed, transformed because the data fed to ML algorithms impact the final solution. And that makes feature engineering critical for your ML applications. Now, there may be many different ways to extract features from raw data, and it requires the understanding of raw data as well as business context. Some of the common feature engineering techniques are imputation and converting like categorical data into numeric data, normalizing the data and treating the outliers, feature binning, which usually involves converting continuous features into discrete, one hot encoding or binarization, uh, feature hashing and grouping, splitting, and representation learning that basically involves extracting features using clustering, embeddings, or generative models, computing aggregate features and scaling them. And there are a bunch of other custom techniques as well that helps data scientists and engineers to feature engineer the raw data. Now, challenges with the ML feature, why it takes so much time and why it is a tedious process, and why it is a known problem with most of the enterprises. Most of the enterprises, they start with building models by running various POCs, and they start with ad hoc data processing and training. These are some of the quickest way to start experimenting with the ML applications. However, these applications and pipeline processes tend to become complex over time. As the number of ML applications increases, it quietly becomes a mess, which is hard to manage at that time. While building the new ML models, engineers and scientists, they often repeat this process of data preparation and feature engineering. They not only waste time, but they also add an overhead. As the same feature keeps duplicated across multiple models, feature used for training and serving can be inconsistent. And as a result, it increases data engineering tech debt. Data scientists and ML engineers, they often work in their own silos, focusing on a specific problem to solve. And they often reuse the same features or same data set. Data scientists and engineers, they repeat these steps of feature engineering without knowing that what has been used by other people. It is hard to share best features that they have identified after spending so much time. Additionally, feature definitions also vary, and different teams at one company might define and name features differently. Moreover, the accessing of documentation of a specific feature is very challenging because there are hundreds and thousands of ML features. There are several other minor challenges as well, but these are some of the key challenges that we see in our current ML application development. Now, as we went through all these challenges, let's understand these challenges using a use case. For simplicity, these use case only list these three data sources and limited number of features. This use case consumes data from structured data sources, flat files, and cloud sources. In reality, the number of features and number of sources are significantly higher. We start the model training with two features. In the first version of the model, model V1, feature A is processed using the data from flat file and cloud sources, while feature B is processed from just cloud sources. In the next version of this model, a few new features are introduced. Features C and D are similarly processed from various sources. Feature A here is also being reused in model V2, but the code and processes are duplicated to recalculate feature A. After multiple rounds of training, testing, the model is finally deployed as a model V3. And again, the common features are duplicated, Possibilities are features in training may be different in production. In this example, feature A is duplicated in all three versions, and it was reprocessed 3 times. It is also hard to search which features are available and which are important features. In this case, feature A was important, but again, we recalculated each time. The reason is there is no unified storage for ML features. With unified and democratized feature serving, these challenges can be easily solved. Now, let's understand how these challenges can be solved using democratization of ML features. We all are aware of data democratization with the evolution of data warehousing, enterprise big data lakes, and emerging tools. Enterprise users can access a variety of data sets. They can play with big data anytime that they want. Similarly, the ML feature democratization means that everyone in the enterprise has access to ML feature that can be used for ML applications. Data lakes, data warehouses, and demo data lakes and warehouses already democratize the access to enterprise data by centralizing the data in a single platform, then empowering the business analyst with visual tools so that they can create charts and dashboards and share with the other stakeholders. No longer they need to know the data sources, where they are coming from, how to query, etc. They could derive the historical insights into the business using these visualization tools. In contrast, data scientists build these predictive models to derive business insights, and they often use these ML features to train and test these models. And one of the effective way of uh, democratization of ML feature is using a feature store. The feature store is like a data warehouse, but it is for data science. It is a central vault for storing documented, uh, curated, and access controlled features that can be used across many different models. Features in a feature store can persist in distributed storage and manage file system as well. And this concept was introduced by Uber with their ML platform Michelangelo way back in 2017. Uber realized that many ML modeling problems use identical features, and there is a substantial value in enabling teams to share these features between their own projects or teams in different organizations. Feature Store provides services to manage shared features and allow an easy access to offline and online servings. Feature Store allows teams to share, discover, and use highly curated set of features for their machine learning problems. And it contains the numerous types of features such as categorical, quantitative, and ordinal. What are the key components of ML Feature Store? We'll go in detail later, but this is just to provide you the highlight of the three components. The first is uh, ML Feature Store interface. It basically provides an easy accessibility of ML features, and features can be shared using this interface. The same interface can be used to add new features or update existing features. Feature storage is the second component, and it stores all the feature data in a structured format so that it can be easily accessible for multiple users. You can relate that to a distributed storage that most enterprise data lakes use to store big data models. The key difference here is big data model serves enterprise reporting and analytics needs, while feature store primarily serves ML applications. The third component is feature registry or metadata repository that stores all useful information about ML features. It is a first stop for all users to know frequently asked questions about ML features. Now let's deep dive into each component and understand what each components are for. Feature store interface, it is an important component to access features from feature store. Now imagine that in enterprise big data lake, you can access the data using either SQL or your enterprise BI tool. Those are the access controlled way of accessing the data. And same way, this feature store interface defines how a user can access these features. User can read the features from feature store, or they can write new features back. Pipeline processes writes this feature back to feature store. And feature store interface provides unified servings of ML features to enterprise users. And this interface can be either SQL supported or a REST API. Details about each method and how they work can be shared using a metadata repository or registry. And most data scientists are comfortable using either SQL or REST API interface. If you're using Python, there are a bunch of frameworks like Flask and Django that can be used to build own feature store API for the interface. There can be other alternatives, but it is up to the enterprise what fits their needs. The second component is feature storage, and this is important component as well. Feature should be stored in structured formats so that users can easily and retrieve them with low latency. Feature store can store all features in variety of data stores, and some of the storage options are Hive, Snowflake, Redshift, Cassandra, Kudu, and several others. The goal here is to store hundreds and thousands of features with historical data and to make them accessible with faster response time. And storage should be chosen depending on the use cases that you have. Basically, for storage, there are two components for the ML feature store: offline and online store. Offline feature store is for serving large batches of features to create training or test data sets, and batch applications which are scoring models using those batches of features. While online feature store serves a single row of feature to be used as a input, and then using the online model, it provides the individual predictions. The offline feature store is typically required to efficiently serve and store large amount of feature data, while online feature store is required to return feature vectors in a very low latency. Example of databases or storage that can be used for offline feature store are Hive, BigQuery, and AWS Redshift. While for online feature store, you can use Cassandra, MySQL, Redis, DynamoDB, and several others. Again, these are some of the widely used, but you can choose your own data store for feature storage. The third component is metadata registry. Here, I have listed this component as the third component, but eventually, like when you have a data ML feature store, this is the first component that the end user will look into. It is the first stop for ML application users to look into which features are available, and it contains all the useful information about the ML features, such as the metadata, business rules, versions, calculation steps, and data pipeline lineage as well. It helps the users to learn how these features are processed, and it should be updated every time the features are modified as well. As I mentioned earlier, it is a first step for users to find out which features are available in feature store. It often offers some of the common traits such as keyword search, a feature job, lineage, data preview, etc. When you think about this feature, you feel like, oh, this is a project by itself. This is important because if you market your features or feature store, people will likely to use it more, and it will streamline your ML application. You can market it as a Wikipedia of your enterprise ML features, where you can save data lineage of a feature and all other useful information that I have mentioned earlier. Now, as we went through feature democratization and ML feature store, now revisit the same use case that we went through earlier, but this time with ML feature democratization. Again, data sources are the same: structured data sources, flat files, and cloud sources for making it simple for this use case. The ML feature store is added as a data management layer to store all those features on top of these commonly used data sources. And it follows the same processing step that we repeated earlier between multiple versions of data models. For example, feature A is calculated using the same sources and gets stored in the feature store. Similarly, feature B, C, and D are calculated and stored in a feature store. Now, ML models in training, testing, and production will use this feature store to access these features. If you remember, model V1 was using feature A and B. So this time it will use these features from ML feature store. One thing to note here is that feature A and B are already processed and model can start using them. When you are working on a new version of the same model, feature A, C, and D, which are already there in feature store, and the model can start using it. Once the model is deployed in production, uh, as it uses feature A, C, A, B, and C, it will be reused again when you deploy the model in production. As noted earlier, feature A is being reused in all three versions. And as features are unified in feature store, feature A is the same for all three versions, and even in training and production. So that's a significant benefit of unifying these ML features. Now, how ML feature store provides feature democratization. Feature store offers a unified feature layer for machine learning where developers, analysts, and scientists can use these features and share with other team members. That way, it promotes the unified feature servings. As a result, there are no duplicate feature processing. The same feature can be used in numerous machine learning models. Users can search available features, share the base features with other users and other teams. That's a key benefit because when they work in and in their silos, they often don't know which features are useful. This sharing mechanism helps them to find out the most frequently used feature, and they can leverage ML application development. Feature will be processed using pipeline processes by data engineers, and later they can be used as many times as they wish. With feature store, users don't need to worry about feature engineering. And this is the same advantage that we saw with data democratization. Users don't need to know the sources of data, how the data is processed, they can start using them. Similarly, with ML feature store, users don't need to worry about a feature engineering. They can start using features from feature store and rapidly build ML applications. Feature stores unify these feature definitions by keeping features and definitions organized and consistent. The documentation of features in Feature Store helps users to create a standardized language around all these features across the organization. And you know exactly how every feature is computed and what information it represents. These are some of the key benefits of feature democratization using Feature Store. Now, as we went through the feature store, and it was first being developed by Uber in 2017 with their Michelangelo platform. And that was the very first feature store that the Uber realized after hearing multiple complaints from data scientists, data engineers, and who are involved in ML applications. The first feature store that they built, it was built using Spark with Hive as their offline feature store and Cassandra as their online feature store. After that, several other like companies started jumping into feature store because as they realized that these ML applications are increasing in various departments, it is very hard to maintain. Hopesworks, they also worked on releasing the open source version of Feature Store. It was also based in Spark, Hive, and MySQL cluster databases. After that, Fist was the Feature Store version from Google. It was built using Google Cloud Services. Zipline was from Airbnb, and it is a feature management layer for Airbnb's machine learning platform, Big Head. StreamSQL was the first commercial feature store developed using Apache Pulsar, Cassandra, and Redis. Tecton is also a managed feature store mainly for AWS. There are several like several other solutions available for enterprise feature store, but they are still in the very early stage. To conclude my talk today, this is like the experience for the first or last 5 years that we have seen for ML feature engineering and ML applications development. The past few years, machine learning has evolved from experimentation to production for hundreds and thousands of companies. This has created an emerging need for more robust and efficient approaches to ML application development, in particular in the most underlooked area of feature engineering. There are numerous challenges, and feature democratization definitely adds value in their enterprise offering. As I mentioned earlier, Feature Store is a way to democratize ML feature, and the rise of Feature Store has triggered a new wave of ML platforms. Adoption is still in early days, but major disruptions are anticipated in the next few years due to the problems enterprises are facing. And most enterprises started building their own feature store, but there will be more push to enterprise feature store for both open source and commercial. And again, like when enterprises are experimenting with ML models, it definitely makes sense to build their own. That's the end of my presentation. Thank you for your time. And if you have any questions, feel free to throw them. Thank you very much.
Thank you, Jayesh. So let's give over attendees some time to type their questions.
Hello, this is Jason. Yeah, again, thank you to be our speaker, and that is a good talk. So, we were talking about the feature engineering. So, we know that machine learning is going to build some models, and so we can detect the patterns in the large scale data set. The key technology is not modeling algorithm, it's how you can clean up the data, how you define the features. So can you give us some basic idea that when we deal with the small data set, like we only have couple sample size, and for each row we may have only 10 to 20 columns. So how to deal with this small data set when we're working on the features. And on the other hand, for some particular case, we have millions rows in the sample size, and we may have 1,000 columns there. And in that case, we need the dimension reduction to somehow clean up some feature. So can you start from the small data set and then the large to see the different technology can play different strategy when we do the feature engineering?
Yeah, I think that's the exactly how most enterprises start with their ML applications. Like when they start small by building POCs, run them, present it, and see if they are useful. So when you are playing with the small set of data, experimenting with the ML applications, it doesn't make sense to have the ML feature store, to have a common a layer of features, because your data set is too small and there are not that many features, I assume. So when bunch of the teams start building the ML applications, and if these features are, or if this data scientist or other teams are using the similar data sources, at that time it makes sense to have something like this data layer. Now, I think with that same question, I will go back to the early days of enterprise big data lake. So before enterprise big data lake, we had data warehouses, which were storing data mainly for our enterprise data sources, but in more relational data sources. So when we had small amount of data, we were just grabbing those data sets and dropping into our data warehouse, building the analytical model so that it can be plugged into any dashboards or visualization tools. So when the data set was small, like what we are doing was we just like dropping the data as one of process, like say copy once, load it once, and you are done. You don't need to schedule a process like ETL or pipeline process in that case. Now, after few iterations, now we have enterprise big data lake to democratize data across the enterprise. So when that happens, when the data volume grows, when there are a bunch of data sources coming at multiple veracity with a variety of data sets, or the big data qualities that we often known as 5Vs. So in that case, we needed some kind of platform known as enterprise data lake where we standardize things. Same way for feature store, like initially when we are dealing with small data set, we might not need feature store, but you never know from when you will jump from small set of data to a large data set. So usually when like these are the things that happens most of the time when the enterprises are playing or experimenting with the ML applications. They start small, gets approval, and start jumping on building the actual applications without thinking on building these blocks of the foundation for the ML applications. So when they start building ML applications and present it to stakeholders, it looks good, and they start adding more and more and more. Once you have, say, hundreds and thousands of the ML applications, it will be very hard to come up with a feature store. So when you draft your ML strategy, you need to have some clear line or some way to democratize this ML feature so that people can use the same feature. Otherwise, like people will create multiple definitions of the same features, have multiple versions of taste and training features, and they run into like multiple issues when they deploy those models in production.
Okay, thank you for your comments. So I know you are working as a senior data engineer. So maybe one very general question: what's the difference between data engineer and the data scientist from your perspective?
Yeah, I think that's definitely a good question. Like for me, how I view data scientists and data engineer is data scientists, they mainly work on building models, identifying which features and which model will solve a specific business problem. And solving business problem means that how much accuracy that they get to a predictive model. The best model they prepare, they usually hand it over to data engineer. So they basically data scientists work on one-off solution, like the standalone solution for ML application. Data engineers, they build the end-to-end solution, uh, scoring pipeline and ML pipeline. They schedule the data flow, the ML feature processing, and the pipeline, like looking into like reading multiple sources, pre-process these features, set that pipeline up so that the data gets refreshed whenever it depends on like if they need daily, hourly, or real-time data sources. They have to draft all those things in their solution. Depending on that, they have to figure out how the scoring will work. The model has been built by data scientists, how they can use the same model with the same set of features that they have been using, and convert it into a scheduled process. The scheduled process will generate more and more scores as the new data arrives. Now, once that process is set, data engineers still need to work with data scientists if there are any other changes in the model, if there are new features that they want to use. Are there any better way, or have they found any drift in the accuracy? Was anything alerted in the result? Depending on that, data engineers will work with data scientists to tweak that pipeline process and make it better. So in short, data scientists will work on one-off process for building the ML application, and data engineers will set that model in a more scheduled or more formal process that generates predictions on top of those models.
Thank you for your comments on my question. So we have one question from the attendee, um, from Galene. So the question is, for the deep learning, the feature engineering became not so important. What's your point?
Yeah, I think for deep learning, like again, it depends if there are some common elements. So I think all these area like feature store may not solve all the use cases, but it solves the use cases where people use the common features and reprocess the same features again and again. Again, like if with the deep learning applications, if the features are kept used again and again, then you can think of having some kind of unified serving for those features. But again, I think it depends on the complexities and mainly, like as I mentioned earlier, feature store mainly stores data as a structured format. So there may be a need, say if there is unstructured data or some way or raw images or other forms of like audio video data. If you want to have some kind of ML applications on top of them, feature store will help to standardize the features. But again, at the same time, we need to think over how they can be stored in an effective way.
Yeah, thank you for your answer for the attendees question. Another question is, um, you are working in gaming industry, right?
Yes.
So can you give us some, examples, the machine learning, the statistic analytics, technology has been applied in gaming industry?
Yeah, I think there are like hundreds of use cases in gaming. Like in game development, it's like completely separate area where deep learning and AI definitely comes into play to make a strategy on the specific game development portion. But I'll talk more on the enterprise ML that we widely use, mainly for customer service, security, marketing, and other stakeholders. So not just with the Rockstar games, but some of the other gaming giants like Activision, Blizzard, Tencent, Fortnite Maker, and several other gaming company as well. They heavily use the data to find the frauds in their games. When I mean fraud is like people usually cheat in the game so that they can make a shortcut or earn money in the short period of time, or use some of the features that are only available to the paid subscription. So it is one key aspect that the gaming company wants to watch and identify this fraudulent activity. That's one of the use case. There are a bunch of others like toxicity in the online gamings, like when people or players play with their fellow players, they use toxic language, and that's definitely affect the gaming experience for the players. So to identify those toxicity, the NLP and ML processing is definitely helping the gaming company. At the same time, as the gaming has its own world and it's like the major part of entertainment industry, so they use various marketing tactics to like leverage the player base and keep players engaged in the gaming. So they use data heavily to find out who are their prime players, how can they target these players effectively, and the data and these features are key component to make that happen. So these are like some of the use cases. And again, on the same side, the customer service is important aspect as well. When something happens, the players just jump on to customer service that, oh, this is happening. And again, this is a very complex environment with the gaming, because the same gaming title may be used on multiple platforms, and for multiple versions, like online versus single player. And there are a bunch of complexities that the maybe 5 players are playing with each other, or hundreds of players are working on a mission. So there are like multiple complexities, and when the issues happen, customer service is bombarded with multiple tickets that, oh, this is happening. So when that happens, usually to reduce the time to solve this kind of issue, the customer service need to pass important information to gaming team so that they can work on solving those kind of issues. So now when customer service gets the information from users that, oh, I'm getting this error, or my balance was this but now it is, say, reduced to zero, or something happened, I can't launch my game, things like that. So these are very important data for the gaming team, and customer service will be the first point who will get this data. Now, if we have ML applications running on this data to find out some of the key patterns of the issues, when that happens, the trending can show you that, oh, this is happening in last 15 minutes. Let's involve gaming team, or let's share some of this data to gaming team so that they can start jumping onto this issue and resolve them as soon as possible. So again, these opportunities are unlimited for gaming. And again, this is not just for gaming, but this can be applied to any industries. I have been working with many industries in the past, like transportation, marketing services, telecom. They have their own use cases where the ML applications can help to leverage or add more values in their business operations.
Yeah, thank you. So today we have one special speaker, Umesh. His topic is, uh, the challenge to use AI technology. I remember his point is, one of the top requirements for the, data scientists is, we need to understand, the domain knowledge, how the business is running. So can you give us some, suggestions of if we want to, get some job in gaming industry as data scientist, what type of knowledge? Except for, SQL programming, definitely we need this type of knowledge, but I'm talking about, the domain knowledge.
Yeah, I would say, like, say, if you are interested in getting the domain knowledge, start playing the video games. That's one way of getting the knowledge in terms of like what are the aspect in the games. Like, for example, when you play Grand Theft Auto or Borderlands or several other titles, they are based on the multi-layered stories, and it is like some of the games are strategy games, some of them are like deep into those steps that they have to make in the game, and they can unlock new things. So it all depends. So again, these are very specific things, like, and it depends on which area that you are targeting as a data scientist. Like, say, if you are targeting on enterprise ML, which is helping mainly the operations of the gaming part, that means like you will be helping customer service, security, marketing, engineering, and development. So those use cases may be different than having ML in the game itself, like AI part of the gaming, like what will be the next strategy, or how will computer react when the user moves in particular direction, and things like that. So computer vision, the audio, video, and the animatics, that's like the different area that ML applications can be used. So first, data scientists need to find what's their interest, like in-game ML or AI tactics, or the enterprise ML tactics. So depending on that, they can get more understanding on the games, like which games are widely used and what are some of the key features of those games, what players like to play the most in that game. And again, I think most of these games, like earlier in the past, it used to be like single copy or single version games. Like once you sell a copy of the game, you are done with the revenue generation. But now the online portion is a major component in getting the revenue. And once you sell, say, a DVD or copy of your game, that's just one part of the revenue. But if you keep your players engaged in the game, then you can generate like 10 or 100 or 1,000 times of the revenue that you already get from the copy of your game. So that's like how you can see as the revenue generation model, and how the ML can impact that part. That's the other area that data scientists can conquer. So now, like getting this knowledge, playing the games, understanding the popular features and how the players are behaving in the game itself, will definitely help data scientists to come up with a better understanding of the gaming industry.
Thank you. Thank you for all the answers. And we will go to our next speaker again. Thank you to joining us, and thank you to all the attendees. It won't be easy to work during the weekend. Okay, so I would like to give the host to our session chair, Helen Chi. She will work with our next speaker, Alexandra. Thank you all.
Yeah, thank you, everyone. Thank you, Jason, Helen, and the people who gave me the opportunity to speak. Thank you, everyone.
Yes, thank you, Jason. Actually, may I ask like a following question to Jayesh?
Oh, yeah, definitely.
Yeah. So so do you see any like obvious trend in the job market during the pandemic for gaming industry for data scientist or data engineer?
Yeah, actually, due to the pandemic, people started playing more and more games. So definitely, like most of the gaming companies are currently hiring because they need more people, and it is very hard to find like proper skill set for the data scientist and the specific use cases that gaming companies are looking for. So definitely, I think one of the recent trend that we had was the hiring bumped up for the gaming companies. The other thing is gaming teams are looking for more ideas. Like these are the features are widely used. What will be the next? Like how we can improve that operation and things like that. At the same time, as the player base got increased, the underlying infrastructures need to be improved as well. Like the ML applications that they have built 3 years ago might not work now because the player base significantly increased. So those kind of challenges that are happening because of COVID-19, and luckily, like gaming companies are helping people to stay away from like stress and getting demotivated from the current situation. They are keeping them entertained using these various titles and updates in the game. So definitely the key industry to look forward in the COVID-19 situation for data scientists and other key skill sets.
Great. Thank you, Jayesh. Yeah, thank you for joining us today.
Yeah, thank you very much.